When you go through this question, you will notice that there are equations of four planes given, and the question is asking something about a fifth plane. So I think the question is driving you to think about the family of planes here. So what is the family of planes passing through the intersection of the first two planes? Can we write it as family of plane 1? That would be the equation of the first plane plus some constant into equation of the other plane, right? That would be the family of planes passing through the intersection of these two planes, and this family contains the line L1, right? That's the line of intersection. Now similarly you could write another family of planes passing through the intersection of the other two planes. That would be x plus 2y minus z minus 3 plus some constant. Now we cannot use lambda because that's a different family now. So we can use, let's say, mu into equation of the other plane, right? And this family will contain the line of intersection, that is L2, right? And the question is asking you something about a plane that contains both L1 and L2. So that plane that contains both L1 and L2 should be common to both the families, right? So for some specific value of lambda and mu, there would be a plane in both the families that contains both L1 and L2, L1 and L2, right? So we can find that specific values of either lambda or mu, right? And then we can get that plane. So then if we just simplify this first family by just clubbing the x terms, that would be 2 plus lambda x, then clubbing the y terms, that would be minus of 2 plus lambda y, then clubbing the z terms, that would be 3 plus lambda z minus 2 plus lambda equal to 0. Similarly, we could simplify the other family. It would be 1 plus 3 mu x plus 2 minus mu y minus 1 minus 2 mu z minus 3 minus mu equal to 0, right? And for some specific value of mu and lambda, these two equations should be the same, right? They should represent the same plane that contains both L1 and L2. So we could say that the coefficients of x, the ratio of coefficients of x and y and z and constants should be either 1 or some other constant, right? So we could write that 2 plus lambda by 1 plus 3 mu must be equal to minus of 2 plus lambda, 2 minus mu, 3 plus lambda minus of 1 minus 2 mu minus of 2 plus lambda minus 3 minus mu must be equal to some constant, right? Say k. So we could write that 2 plus lambda is 1 plus 3 mu is k, so 2 plus lambda would be k plus 3 mu k, right? There is, if we use the other equation, then minus of 2 plus lambda is 2 minus mu, that should also be k, so 2 plus lambda, if I multiply everything by minus 1, then mu minus 2 into k. But we already know that from the first, 2 plus lambda is k plus 3 mu k, that should be equal to mu k minus 2k. So if we simplify this, then 2 mu k is coming out to be minus 3k. We cancel k, we get mu is equal to minus 3 by 2. So we got some specific value of mu. So if we just replace that, then we could find the equation of the plane that contains both L1 and L2. So let's replace that here. That would be 1 plus 3 into minus 3 by 2. I'm just replacing mu here. X plus 2 minus minus plus 3 by 2 y minus of 1 minus minus plus 2 into 3 by 2 z minus 3 minus minus plus 3 by 2 equal to 0. Now I'm going to write this up. After simplifying, it would be 1 minus 9 by 2, that would be minus 7 by 2 x plus 7 by 2 y minus 4 z minus 3 by 2 equal to 0. We can get rid of the 2, so minus 7x minus plus 7y minus 8z minus 3 equal to 0. Now, so that is the equation of the plane that contains both L1 and L2. So now they are asking the distance of origin from this plane. So let's find that distance, and that distance would simply be mod of the constant, that is minus 3, and root of divided by root of 7 square plus 7 square plus 8 square, and that would be 3 by root of 49 plus 49 plus 64, that would be 3 by root of 162, that would be 3 by 9 into root 2. So after simplifying, we get 1 by 3 root 2. So that should be your answer.